All right, we're going to talk about example 4, but first we have to go over some information. So in geometry, biconditional statements are used to write definitions. And we use definitions all the time, right? A definition of a triangle, a definition of a square, and a definition of a rectangle. There's all different types of definitions. So definitions, we use them all the time, and they're actually from biconditional statements, right? And biconditional statements are from a true conditional and a true converse, okay? So you can kind of start to see how all of this builds on top of each other. So we just talked about biconditional statements, right? And so that means that we are going to be moving into writing and talking about definitions. Okay? So a definition, what that is a definition is a statement that describes a mathematical object and can be written as a true biconditional. So a statement that describes a mathematical object and can be written as a true biconditional. And since it's written as a true biconditional, that means the conditional is true, and it also means that the converse is true. So you see how all this stuff is just building on top of each other? So before we do the problems, we have to kind of go over a few definitions. So the first definition is a polygon. A polygon is a closed plane figure, okay, formed by 3 or more line segments. Okay, so it's not lines, it's line segments, 3 or more, a closed plane figure. So it's important to know, well, what is a closed plane figure? So that would be something like this. This is closed planed. Okay, something that isn't closed would be something that looks like this, where it's open. Okay, so that's not a polygon, okay? They have to be closed plane figures by 3 or more line segments. So it could be something like this. That could be a polygon, right? But this could not. It's closed, but why is that not a polygon? It's not a polygon because this is not a line segment. Line segments have to be straight. So that is not a polygon. So a closed plane figure means it can't be open like that. It has to be closed, and it can be formed by 3 or more line segments. They have to be they can't be go on and on forever, right? It can't be something like this, right? That's not a polygon because they're line segments. They're not lines that go on forever, okay? So polygon, a closed plane figure formed by 3 or more line segments. So one of those polygons would be a triangle, which is defined as a 3-sided polygon, okay? A polygon which is closed, it has 3 sides. You know what a triangle is. And then a quadrilateral, well, it's kind of interesting, right? So tri like triangle, tricycle means 3-sided polygon, and then quad means 4. So that's going to be a 4-sided polygon. Okay, so really anything that has 4 sides and it's a polygon, so they're line segments. So, 1, 2, 3, oh man. Oh, I'm gonna run out of room. I'm gonna have to make this one longer. It's gonna have 4. Okay, 1, 2, 3, 4. That wasn't a beautiful one. That was kind of weird, but it is they're straight. 1, 2, 3, 4. It's 4-sided. 1, 2, 3, 4. Okay, a square, rhombus. There's just a lot of different options. You can go trapezoid. There's all different types. Those are all quadrilaterals. They all have 4 sides. Polygon, they're all closed, right? They're not open like that, and they don't have any curved lines. So, quadrilateral, 4-sided polygon. Okay, so helpful hint. Think of definitions as being reversible. Postulates, however, are not necessarily true when reversed. So definitions, they can be reversible. You can say the first part and then the second part, or you can say the second part and then the first part. So it's kind of like that biconditional where P, it's that double arrow, right? Where they're both true. The conditional is true and the converse is true. So that is the reverse part of it. So let's look at example 4. So what example 4 states is that write each definition as a biconditional. So they're going to give us definitions, and we have to write it as a biconditional. Okay, it says a pentagon is a 5-sided polygon. Okay, so with this, we have to figure out, right, a biconditional is P if and only if Q, right? So we have to figure out what the hypothesis is and what the conclusion is. So we have a pentagon and we have 5-sided polygon. So it's hard to make that into a sentence, right? Like, so we have to figure out what the word is. And you just kind of have to do these, and then you see the pattern and you kind of get used to it. So what we're talking about here is we're talking about a figure. So what we would say is we would say a figure is a pentagon. So that's going to be our hypothesis, and this is going to be our conclusion. A figure is a pentagon if and only if and only if a figure, or you could say it, or if it is, or if a figure is a 5-sided polygon. So I used a figure twice just because I want you to get used to inserting that word, a figure, and it's not there. So that's what kind of makes it a little tricky, right? Because it just has pentagon and 5-sided polygon. So this is our hypothesis, this is our conclusion, but we have to insert that word, which is a figure. So a figure is a pentagon if and only if a figure is a 5-sided polygon. Or you could write a figure is a pentagon if and only if it is a 5-sided polygon. Okay. So let's look at this next definition, and we're going to write that as a biconditional as well. So this says a right angle measures 90 degrees. Okay, so we have right angle and measures 90 degrees. Okay, so this is going to be our hypothesis. This is going to be our conclusion, right? And we're writing that biconditional, which goes both ways. And okay, what is the word? Like, we inserted the word a figure here. What is going to be the word that we insert here to this definition to make it a biconditional? What are we talking about? Well, we're talking about an angle. So that's going to be the word that we're going to insert in there. So we're going to say an angle is a right angle if and only if it measures 90 degrees. So there you go. There's our biconditional from our definition. Okay? Notice that these are our key words right here, if and only if. Okay? So when you're doing a biconditional, you're not putting that if and then, so don't do that, right? These are the keywords, if and only if, and you put it in the middle, and it separates the hypothesis from the conclusion. Okay? Okay, so let's go here to check it out. Example 4, it says write each definition as a biconditional. So we have a quadrilateral is a 4-sided polygon. So we have to figure out, okay, from that definition, what is our hypothesis and what is our conclusion? Okay, well, we have a quadrilateral and then we have a 4-sided figure. So this is going to be our hypothesis and this is going to be our conclusion, right? What is going to be that word that we insert in there? What are we talking about? We're talking about a figure. So we're going to say a figure is a quadrilateral if and only if it is a four-sided polygon. So there you go. That would be our biconditional statement with our keywords right there. Okay. Let's do the last one right here. It says the measure of a straight angle is 180 degrees. So the measure of a straight angle is 180 degrees. So what do we have there? What do we have? The measure of a straight angle is 180 degrees. So we have this idea of a straight angle, right? That's going to be our hypothesis. And then we have this 180 degrees. Okay, so that's going to be a part of our conclusion. So what word do we insert in there? What are we talking about? We're talking about an angle. So we're going to say an angle is a straight angle if and only if. I like saying that. If and only if. If and only if. If, oh man, and only if its measure is 180 degrees. And there you have those keywords of the biconditional again. Right there. Perfect. So, and remember what we talked about before. These definitions are reversible. So, we could say a pentagon is, a figure is a pentagon. Let's start back here and let's reverse them and see if they make sense. A figure is a pentagon if and only if a figure is a five-sided polygon. Okay, well, let's reverse it. A figure is a five-sided polygon if and only if it is a pentagon. Well, yeah, they're both true, right? How about this one? An angle is a right angle if and only if it measures 90 degrees. Okay, well, let's reverse it. If an angle measures 90 degrees, an angle measures 90 degrees if and only if it is a right angle. And the reverse is true as well. What about this one down here? A figure is a quadrilateral if and only if it is a four-sided figure. And then if we reverse it, a figure is a four-sided polygon if and only if it is a quadrilateral. Yeah, that one can be reversed too, and it still is true. What about the last one? An angle is a straight angle if and only if its measure is 180 degrees. Or we could say an angle measures 180 degrees if and only if it's a straight angle. So you can just see how, I mean, it's kind of cool. Like these, you can write them this way or you can write them the other way, which shows that the conditional is true and also the converse is true as well. So that is it for this section, and I look forward to seeing you next time. All right, see you later. Bye.